Somewhere 400,000 kilometers from a single planet, billions of pieces of ice are falling right now. Not toward the ground, not toward anything at all. They're falling around a world so large that Earth could disappear inside it 1,000 times over and still leave room to spare. This is Saturn. Tonight, we're not going to rush past it the way most documentaries do. We're going to slow down. We're going to drift quietly into the space around this giant and let its rings carry us somewhere calmer than where we started. You don't need to remember any of this. You don't need to hold on to a single fact. Just let your eyes close if they want to. Let your body sink a little deeper into the bed. And let Saturn do what it's done for 4.5 billion years. Turn slowly in the dark without asking anything of anyone. Somewhere above you tonight, if the sky is clear, Saturn is already there. A small, steady point of gold, holding a secret that took humans thousands of years to even begin to see clearly. We're going to spend some time with that secret now. There's no rush. There's nowhere else to be. Welcome to the quiet universe. Let's begin. Picture the approach slowly, the way a spacecraft might see it after years of travel. At first, Saturn is only a smear of pale gold against the black, no different from a star. Then, hour by hour, it grows. A disk, a shape, and finally, unmistakably, a planet wrapped in something that doesn't belong to any other world we know. Saturn itself is enormous, a ball of hydrogen and helium so large that more than 750 Earths could fit inside it. It has no solid surface to land on, just layers of gas that thicken and darken the deeper you go, until pressure and heat turn the atmosphere into something stranger than air or ocean. But it isn't Saturn's size that stops people. It's what surrounds it. From far enough away, the rings look almost like a single, solid object, a flat, glowing halo, tilted slightly, wrapped around the planet's middle, like a ribbon around a gift no one has opened yet. They stretch out for hundreds of thousands of kilometers. And yet, if you measured their thickness, the actual height of the rings, top to bottom, in most places it's only about 10 meters. 10 meters, stretched across hundreds of thousands of kilometers. If Saturn's rings were shrunk down to the width of a football field, they'd be thinner than a sheet of paper. Something that wide, that thin, that patient. Let's get a little closer and see what they're actually made of. If you could stand at the edge of Saturn's rings, impossible of course, but imagine it anyway, you wouldn't see a solid disk at all. Up close, there's nothing sleek or seamless about them. They're made of countless individual fragments, mostly water ice, some no larger than a grain of sand, others as big as a house, drifting past each other in a slow, endless procession. Each piece follows its own orbit around Saturn. Nothing out here is glued together. Every fragment of ice is, in its own small way, its own tiny following the same laws of gravity that hold planets around stars, just on a much quieter scale. And yet, seen from far away, from Earth, through a telescope, on a night when the air is still, they blur into something that looks impossibly smooth. A halo, a single perfect line of light wrapped around a world. That's the strange trick of scale. Up close, motion, chaos, countless separate paths. From a distance, stillness, order, a single unbroken ring. Most of these ice fragments are surprisingly bright, almost pure white, which is part of why the rings shine so clearly, even from hundreds of millions of kilometers away. Some scientists think the ice may be so reflective because it's constantly being polished, worn smooth by countless small collisions, fragment brushing against the fragment, over and over, for longer than humans have existed. There's something quietly beautiful in that the shine which first caught Galileo's eye 4 centuries ago might come from nothing more dramatic than billions of tiny, gentle collisions repeated patiently across an unimaginable span of time. Let's look at where all this ice might have come from in the first place. For a long time, scientists assumed Saturn's rings were as old as Saturn itself, a leftover halo of material from the early solar system, spinning quietly around the planet since almost the very beginning, 4.5 billion years ago. But the deeper we've looked, the less that seems to be true. One leading idea is that the rings came from a shattered moon, an icy world that wandered too close to Saturn and was slowly pulled apart by its gravity, piece by piece, until nothing was left but this, a wide, glittering memory, still circling the place where it was undone. Another idea points to a passing comet, torn apart the same way, its ice scattered into the orbit we see today. What's strange, what's almost hard to sit with, is that data gathered by the Cassini spacecraft in its final years suggested the rings might be far younger than Saturn, not 4.5 billion years old, possibly just a few 100 million years old, young enough that early dinosaurs may have been walking around on Earth under a Saturn that had no rings at all. If that's true, it means the rings we see tonight aren't some ancient, permanent fixture of the solar system. They're something closer to a passing moment, vast on a human scale, brief on a cosmic one. There's a strange comfort in that, if you let yourself sit with it. Something can be enormous and beautiful and feel eternal and still only be visiting. Maybe that's worth carrying with you as you drift off tonight, not as something to worry over, just something to notice, that even a giant's rings are, in their own way, temporary, and that we happen to be here, small and warm in our beds, during the part of the story when they're still shining. Look closely enough at Saturn's rings, and they aren't one continuous sheet at all. They're closer to dozens of thin ribbons, nested one inside another, separated by gaps of empty space. The widest of these gaps is called the Cassini division, a dark band nearly 5,000 kilometers wide, easily visible even through a backyard telescope on a clear night. For a long time, it looked like nothing more than an empty scar across the rings. But nothing about it is an accident. The gap exists because of a moon named Mimas, orbiting much farther out. Any piece of ice that drifts into the Cassini division ends up circling Saturn at almost exactly half the speed of Mimas, a rhythm so precise that Mimas's gravity tugs on it at the same point in its orbit, again and again. Every single lap. One small pull wouldn't matter. Repeated for millions of years, it's enough to sweep the gap clean. No collision, no explosion, just a patient, quiet tug, repeated for millions of years, until an empty space opened up and stayed empty. Smaller gaps have their own tiny caretakers. A moon called Pan, barely the width of a city, orbits directly inside a narrow gap of its own, clearing a path through the ring material as it goes, like a plow leaving a clean furrow behind it. Another small moon, Daphnis, does something similar nearby, its gravity sculpting soft, wavy edges into the ice on either side of its path, the only visible trace from so far away that something is moving through the dark. Farther out, two more small moons, Prometheus and Pandora, orbit on either side of a thin, narrow ring, gently keeping its ice from drifting apart. Astronomers call moons like these shepherd moons, small, quiet workers doing the same patient job for billions of years with no audience and no reward. Nothing but gravity and time. None of this was obvious, even once humans started looking. In 1610, Galileo Galilei pointed one of the very first telescopes at Saturn and saw something he couldn't quite explain. The image was blurry, the telescope weak by today's standards, and what he saw looked less like a ring and more like two smaller shapes on either side of the planet. Handles, almost. He wrote, confused, that Saturn seemed to have ears. For decades, no one could agree on what those shapes actually were. Some astronomers even reported watching them slowly disappear, only to reappear years later, which we now know happens when Saturn's tilt turns the rings edge-on to Earth, thin enough to vanish from view for a while. It wasn't until 1655 that the Dutch astronomer Christian Huygens, working with a sharper telescope, finally saw it clearly. Not ears, not companion moons, but a single, thin, flat ring, circling Saturn without ever touching it. 20 years later, the astronomer Giovanni Cassini noticed the dark gap that would eventually carry his name. For the next 3 centuries, that's largely where our understanding stayed. Then, in 2004, a spacecraft named after that same astronomer, Cassini, arrived at Saturn and began orbiting up close. For 13 years, it watched the rings shift and shimmer and found moons no one had ever seen. In its final months, it did something no spacecraft had done before. It threaded the 2,000-kilometer gap between Saturn and the inner edge of its rings, again and again, 22 times, gathering as much as it could before the end. In September of 2017, with its fuel nearly gone, Cassini turned towards Saturn one last time and let itself fall. That fall, Cassini's fall, told us something important about the rings themselves. As the spacecraft passed through the gap in its final orbits, it flew through faint traces of ring material, drifting down towards Saturn's equator. Ice, quietly raining out of the rings and into the planet's atmosphere. Scientists already had a name for this from years of earlier, more distant observations. Ring rain. It isn't rain the way we know it. Tiny, electrically charged particles of ice get caught by Saturn's magnetic field and pulled down along invisible lines, falling out of the rings and into the upper atmosphere, where they simply vanish, turned back into the same water and hydrogen that make up so much of Saturn itself. It happens constantly, quietly, right now as you listen to this. By some estimates, the rings lose enough water this way to fill an Olympic-sized swimming pool roughly every half hour. Multiply that across a year, 1,000,000 years, and you start to understand. The rings are not permanent. They are draining, slowly, back into the planet they surround. At the current rate, scientists estimate the rings could be gone completely, somewhere between 100 million and 300 million years from now. On a human scale, that number is meaningless, longer than our entire species has existed, many times over. On the scale of Saturn's 4.5 billion year life, it's the blink of an eye. A brief, glittering exception, not the rule. Which means, of everyone who has ever lived, and everyone who ever will, we happen to exist during the narrow window when Saturn still has its rings at all. Not at the beginning, not at the end, somewhere in the quiet middle, when the light still catches the ice just right. Cassini, in its own way, spent its last 13 years memorizing every detail it could reach, and then, instead of drifting away forever, fell into the planet it had come so far to understand, sending data back until the very last second of contact. There are worse ways to end a long journey. We've come a long way tonight, around a planet larger than 700 Earths, through rings made of 1 trillion small separate pieces of ice, past tiny moons that have spent billions of years shepherding light with nothing but gravity. None of it needs to be remembered. None of it is a test. Somewhere above you, right now, whether the sky is clear or clouded, hidden by daylight or lost behind city lights, Saturn is still turning. Its rings are still catching sunlight that left the sun over an hour ago before it ever reached them. Ice is still falling, slowly into the gold clouds below. It doesn't need you to watch it happen. It was doing this long before you existed, and it will keep doing it, quietly, for 100 million years more. Whether you're awake for any of it or not. So you don't have to stay awake for it either. There's nothing else you need to do right now, nothing to solve, nowhere to be. Just let the rings keep turning, slowly, quietly, somewhere out past the dark, while you rest. If Cassini could spend its final moments falling gently toward something vast and old and beautiful, sending back everything it saw until the very end, maybe that's not a bad way to close your own day either. Let go slowly, send whatever's left of today out into the quiet, and rest. If this helped you drift off, you're welcome back anytime. There's always another world waiting here, out past the dark, whenever you're ready to sleep again. Good night.